Farmcraft. I'm John, and this is a ram pump. Now, these things are really cool. This pump is able to pump water uphill using only the water that's feeding it to do so, and it can pump it higher than the source of the water. No, it's not a perpetual motion device, and it doesn't break any laws of physics, but when you first hear about them, it does seem kind of like black magic. There's no motors, there's no wires, there's just a couple check valves here, and the thing is able to pump water. This one has been used before, but I'm going to kind of rebuild this because I want to use it to feed the pond that I built, and we're going to use this to try to help maintain that level. So we'll look at that later, but I want to break this down and how it works because it's really cool, and if you kind of do it in a stepwise fashion, you're going to understand how these things are functioning, because right now it seems like a lot going on. You've got a check valve here, and water flowing and then stopping, and how does it all work? Well, we're going to go through all that, so let's get into it. All right, let me show you my setup here. This is our water supply. I've set this bucket up. It's beside my hydrant, but they're not connected. I'm going to be refilling the bucket through this black hose when I open this valve here. But that ensures that the only thing that can drive the water flow is gravity. It's just the height of this. And that hose is already full, so it's ready to siphon. And I've got a valve on the other end. So let's take that down to the other end and we will open the siphon, because I want to show you water hammer. That's the first thing you need to understand in understanding a ram pump. Now, I remember when I first heard the term water hammer, I thought it was kind of a strange term, and it didn't make a lot of sense to me, but that's because I didn't know what it was. It actually makes perfect sense, and I'm going to show you why. So we should siphon just fine, and we are. And as long as the water remains in that bucket, this siphon will continue to flow. So we're not that low. We're probably maybe 5 feet lower down here than we are up there at that bucket. We are going to induce some water hammer on this, and all I have to do that is rapidly close this valve. So you didn't see anything, but the pressure spiked when all that moving water in this hose, the entire length of it, all that moving water, which is incompressible, and all its inertia had nowhere to go, it all ended up slamming into that valve. And that's what's called water hammer. Water hammer is something that on a lot of water flow, piped systems, you try to avoid because it's hard, especially when you have high flows and high pressures. It's hard on the components. That is the source of power for your ram pump. That is really what's making it work. So stick with me on the water hammer for just a second longer. I want to show you something. All right, so why is it water hammer? Well, here's an actual hammer, and that would equal or be analogous to the amount of force that's on the anvil right now. It's just the weight of gravity pulling the hammerhead into the anvil. This is the water column. This is the valve. Obviously, that doesn't hurt. I'm not getting much force there. If I want to get some force, yeah, I'm not going to do that. In order to get some force, you get the hammer moving. You make it a dynamic system so that the hammer builds up inertia, builds up energy, and then you stop it suddenly, and you get a lot of force out of a hammer, a whole lot. Just a 20-pound sledgehammer, you can make many, many tons of force in that instant. So that's the exact same thing you're doing with the water. You're getting the whole water column moving, and then you're stopping it, and that gives you a lot of force. So now you understand water hammer. It's actually a pretty good name, isn't it? This video